Good morning, students. In the last class, we discussed about the vector algebra, that is vector addition. That is by doing adding the two vectors by the methods of triangle law of addition and parallelogram law of addition. Right? So that is if we have two vectors. So considering this one as one vector A, if we add this vector with the another vector B, then we can add this two vectors by the two methods. So one is triangle of vector addition. So in that, what happens means the tail end of the one vector, that is vector B, is joined with the end of the another vector, right? So here tail end of the vector B is added to the end of the vector A, right? So this becomes vector A and this becomes vector B. So these two vectors represents the two sides of a triangle which are taken in an order. Then the resultant gives the third side of the triangle which is taken in the opposite direction, right? That is opposite order. So this gives the resultant. That is vector C is the resultant. Then we can say vector C is equals to vector A plus vector B. Right? So this is by the method of triangle law of addition. Right? So in the same way we can add these two vectors by the parallelogram law of addition. So in parallelogram law of addition, the tail end of one vector is joined with the another tail end of the vector A. Then these two vectors becomes co-initial vectors, right? So if you write means here is vector A and tail end of this vector B is, so this becomes vector B. Right? Now if we complete this parallelogram by drawing parallel sides, so we get one parallelogram, right? So this becomes vector A and this becomes vector B. So now these two vectors represents the adjacent sides of the parallelogram. Then the resultant is given by the diagonal of this parallelogram, right? So this is the diagonal. So this diagonal gives the resultant. So that can be represented either by C or by R, right? So here, if we write C is equals to vector A plus vector B, right? So this is about the triangle law of addition and parallelogram law of vector addition, right? So in the similar way, we can subtraction of vectors, right? So as we did the triangle law of addition and parallelogram law of addition, in the similar way we can subtract the two vectors, right? So for that, right? So now if you observe here, if you want to subtract vector A minus vector B, right? So here we have vector A subtraction, that is here we have vector B. So this can also be written like this, right? So vector A plus of, here we can write minus, this one is the vector B, right? So here plus into minus, what we will get? Minus, right? So as we studied, that is unlike vectors, right? So they, if two vectors having equal magnitude but opposite in direction, then if we call this one as vector A and here we call this one as vector B, then we can write vector A is equals to minus vector B. So this one is also called as negative vector, right? So minus B is opposite to that of the direction is opposite to that of the vector A. So here minus B means what happens? So this direction will be reversed. Magnitude will be remain same, but the direction will changes, right? So if we rearrange this one means keeping this as is. So this one is vector A plus. So this becomes what? The direction will change means the arrow mark will come downwards. So the magnitude remains same, right? So this becomes minus vector B. Now by using triangle law of addition, we can calculate the vector A minus vector B, right? So the triangle law of addition is keeping A as is, right? So this one is vector A and vector B. The tail end is joined with the head end of the first vector. Then so this becomes minus vector B, right? Then these two represents the two sides of the triangle which are taken in the order. So if you observe here, this is in the clockwise direction, then the resultant will be taken in the opposite direction. That means the resultant will drawn from here like this. So this gives what? Resultant, that is vector C. So that means vector C is equals to vector A minus vector B. So this is about the subtraction of vector. So in subtraction of vector, what we did means we will take the negative vector, right? So we can write A minus B is equals to A plus of minus B, right? So if you multiply plus into minus, again we get the minus. So we are taken this vector as the negative vector. That means its magnitude remains same, but the direction will opposite to that of the initial one, right? So if you observe here, so the direction is towards the up. So here we get the direction towards downwards, right? So now we can subtract these two vectors by the method of triangle of addition. So here vector A and vector B are the two sides of the triangle, then the resultant will give the opposite side, that is the third side. That one is the vector C. So vector C is equals to A minus B, right? So in the similar way we can simplify this one in the method of parallelogram also, right? So here if we add these two, then so this one is vector A and here we have vector B, because tail end of vector B is joined with the tail end of the vector A. So here this gives minus vector B, right? So if we complete the parallelogram like this, so diagonal gives the so diagonal gives what? The resultant, that one is like this. So this gives vector C, right? So we can subtract the two vectors by the method of triangle of addition and subtraction, parallelogram law of addition, right? So this is about the subtraction of vectors. So addition of vectors and subtraction, that is addition of vectors follow the laws, that is it follows the commutative law and also the associative law, right? So the addition of vector follows the commutative law, that is A plus B, vector A plus vector B is equals to vector B plus vector A, that gives the commutative law. right? So vector addition follows the laws, that is, one is commutative law and another one is associative law. So if we consider two vectors, that is vector A plus, again I will take this one as vector B, right? So if we add A plus B, right, so we get resultant vector A, and here we have vector B, and the resultant C is equals to vector A plus vector B, right? So this one is the addition of vector A plus vector B. So similarly, commutative law means A plus B is equals to B plus A. Now we start with this one. First, I will take this one here as it is. Then I will join the vector B, that is tail end of this vector B is joined with the head end of the vector A. So observe here. Then we get the resultant C is equals to A plus B. Now B plus A means I will keep this vector as it is, that is vector B, right? Now I will join the tail end of vector A is added with the head end of the vector B, right? So this one is the vector A, right? So vector B here and vector A is here. So this vector, that is tail end of this vector, is added with the head end of this vector, right? So if we observe by the triangle law of addition, so these two gives the two sides of the triangle, right? So the third side gives what? The third side gives the resultant, right? So the third side is which is taken in the reverse order. So if you observe here, so this one is in the clockwise direction. So right, so the reverse order means anti-clockwise direction. The resultant is in the anti-clockwise direction. So here this one is the vector B. Right, now we get the resultant like this, that is vector C is equals to vector A plus vector B. Now if we observe here, so this one is vector B plus vector A. Now if you observe here, in these two we have the resultant the same direction and it has same magnitude, but we added A plus B and here we added B plus A. So the resultant magnitude C, the resultant gives the two red lines. If you observe here, these two are parallel to each other, that means the resultant A plus B is in the same direction with the resultant B plus A. Hence, the triangle of addition obeys the commutative law. That means vector A plus vector B, that is equals to vector B plus vector A. Right? So this one for vector B plus vector A, first we taken vector B, then joined vector A. So here first we taken vector A, then joined with vector B, right? So this is the commutative law, right? So considering two vectors, so here we have one vector A and here we have another vector B. So first we add A plus B, that is keeping A as is. The tail end of this vector is joined with the head end, then we get the resultant C is equals to A plus B, right? So now second is keeping B as it is, adding the vector A, that is tail on end of this vector A is joined with this vector B, right? So we get the resultant C is equals to B plus A. So if you observe these two directions, so both the directions are same, hence we say vector B plus A is equals to vector A plus B. So this one is the commutative law, right? Next, associative law. So next law is the associative law. So here we are considering the three vectors. Vector A, vector B, and third one is vector C. Right? So now first we add vector A plus vector B, then with the vector C. Right? So first we add vector A, vector B, then with the vector C. Right? So for this, keeping vector A as is, then the tail end of this vector B is joined with the head end of the vector A, right? So now we get here the resultant is like this, right? So this resultant is vector A plus vector B, right? So now we add this vector C with this resultant A plus B, right? So joining the tail end of this vector C to the resultant of vector A plus B. So that means we draw like this. So this one is the vector C. So now this resultant vector A plus B and vector C represents the two sides of the triangle, then the resultant will give the third side, which is opposite to that of the order. So this gives the resultant, right? So resultant we get here what? Vector A plus vector B plus vector C, right? So first considering three vectors, vector A, vector B and vector C. So first, to prove the associative law, that is A plus B plus C, that is A plus B plus C is equals to A plus B plus C, right? So here first we add these two, A plus B, A asterisk and B joined with, we get the resultant A plus B. Now this resultant is added by the vector C, right? So now we get the resultant A plus B plus C, right? So this one is the first one. So in the similar manner, next I will draw here for second, A plus of B plus C. That means first we need to add vector B and vector C, then we can add vector A, right? So for vector B, keeping asterisk, so this one is vector B, right? To add the vector C means the tail end of this vector is joined with the head end of this vector A, right? So this one is the vector C. So the resultant of these two vectors is given here, that is vector B plus vector C, right? Now we need to add vector A. So this vector, now this vector is added with the resultant of this vector B and C, right? So for that, the tail end of this vector is added to the head end of this vector, right? So here this gives vector, a little bit complicated this one. So this one is the vector A, right? So now the resultant will give this B plus C and vector A gives the two sides of the triangle, then the resultant will be the opposite one. That one is, I will draw from here. So this gives vector B plus vector C plus vector A, right? So now observe here, so this vector is parallel to this vector, right? So if you observe here, it has direction like this, means here also this vector has the same direction and these two has the same magnitude. So hence the associative law we can write vector A plus of vector B plus vector C is equals to vector A of B plus C, right? So this is the associative law. So vector law of addition obeys the commutative law along with the associative law, right? So this one is, I will need to change this direction. So anyhow, these two are parallel, right? So this is about the laws of vector addition, that is commutative law and also associative law. So next, the topic is resolution of vector, right? Resolution of vector is nothing but if any vector we have, right? So this is one vector, right? So if we consider this vector as vector A, so this vector can resolve into its components, that is we can split this vector into its components, so that one we call as resolution of vector, right? So we can split this vector in vector A is equals to some other form, vector C plus vector B, right? So then we call vector C and vector B are the components of the vector A. So that process we call as resolution of vector, right? So if we split this vector into its perpendicular components along with the axis x and y and z, then those components are called as rectangular components, right? So if we split this vector along horizontal and vertical, then those components are called as rectangular components. So what is resolution of vector is, simply we can say the splitting of vector into its components, so that one we call as resolution of vector, right? So if we split this vector into its horizontal and vertical component along the axis, then those components are called as rectangular components, right? So if we plot the axis, so this one is x axis and here is y axis, right? So if we split this vector A into the components along x axis and the components along y axis, then those components are called as rectangular components. So that is, this one is OA, right? So vector A is represented by OA. So now drop the perpendiculars from A along x axis and A along y axis, right? Like this. So drawing the perpendicular, here it is AM and here it is AN, right? So now these components OM and ON, so these components we call as rectangular components, right? So for example, if I take here the component B and here it is component C, right? So now the vector B and vector C are the rectangular components of vector A. We can say vector B and vector A are the rectangular components of vector A. That is, we are splitting this vector along x-axis and along y-axis, right? So if we have vector B, means this vector has magnitude and also direction, right? For this vector b, that is OM, can written as it has magnitude along with the direction. So that is vector b has the magnitude b. So and it is along which axis? It is along x-axis, right? So b is along x-axis, so its magnitude is represented by b or modulus of b into I cap. So similarly, vector c has magnitude c and it is along which direction? It is along y direction, means modulus c into j cap, right? So vector b has magnitude and also in direction, and vector c is also the magnitude and also direction. So these magnitude components are called as rectangular components. So as we written here, vector a is equals to vector c plus b or vector b plus vector c. Then if we rearrange that one, vector a is equals to vector b plus vector c, right? So we are splitting this vector a into vector b plus vector c. Now vector b, we have b into I cap plus c into j cap. So this one is the vector a. So b is the magnitude of the rectangular component OM and c is the magnitude of the rectangular component ON, right? So if this vector makes an angle theta with the x-axis, right? So from the geometry, from triangle OAM, right here, from triangle OAM, right? Sin theta is equals to, so sin theta is equals to opposite by hypotenuse, right? So opposite side is what? AM. So hypotenuse is vector A, right? So AM by OA. So sin theta is AM OA, right? So we need AM which is parallel to NO, right? So we can write this one as NO divided by OA. So or ON is equals to OA sin theta. We can write like this, right? So what about OA? OA is the magnitude, that means ON is equals to A sin theta, right? So OA has the magnitude A and sin theta is the direction. So we can written ON, that is magnitude of C. We can write this one as A sin theta, right? Similarly, from the triangle cos theta is equals to adjacent side by hypotenuse. So adjacent side is OM and hypotenuse is OA. So we need OM is equals to OA cos theta. So here OA can be written as A cos theta. So this one is OM. Right. So otherwise I will write here, we change this one B I cap and C J cap as OM I cap and ON J cap. So here also we can change from this OM I cap and ON J cap. Now we get the values ON and OM. Now substitute here. So vector A is equals to, so OM we have A cos theta into I cap plus ON is A sin theta into J cap, right? So vector A can be written as A cos theta into I cap plus a sin theta into j cap. So that means if we resolve any vector along horizontal and vertical, that is if we resolve any components along horizontal and vertical, then always the horizontal component which makes an angle theta, so that horizontal component is always the value a cos theta. So the vertical component is always it is a sin theta, right? So these are called as rectangular components, that is a cos theta and a sin theta, right? So from here we get the resultant magnitude of these two ON and OM, right? So for OA, the magnitude of OA is equals to square root of ON square plus OM square, right? From Pythagoras theorem we can written as OA square is equals to OM square plus AM square, right? So AM is equals to ON square. We have these values, that is OM is a cos theta whole square plus a sin theta whole square, then we get a square plus a square, we can take common a square, we get sin square theta plus cos square theta. So from trigonometry sin square theta plus cos square theta is what? 1. So we get a square, here we have OA square, so from this we can say OA is equals to A, right? So this magnitude A is resolved into these two components, so we can check here, right? So we get the magnitude as A itself, right? Now the direction angle theta, so for that so this gives the magnitude and we want the direction means, that is tan theta is equals to opposite side by adjacent side. So opposite side is AM, that can be written as ON divided by OM. So AM is what? So here AM the same one, right? So here no need to find the direction. So this is about the resolution of vector, and these components are called as rectangular components, a cos theta and a sin theta, which depends on the factor what? The angle which is inclined, right? So if we take one more example means, so I will take same vector A, but here the angle is inclined with the y-axis. So this one is y-axis, and here we have x-axis, right? So now if we find the components that is along y-axis and along x-axis, then here we get a cos theta and here we get a sin theta. So we can simplify and we can check this one as this method, right? From considering triangle OAM, here also we considering triangle OAM, here we have theta, right? So cos theta is opposite adjacent side by hypotenuse and sin theta is opposite side by adjacent side. So if you observe here, so along here I will write the components. Here we have a sin theta and here we have a cos theta, right? So if you observe here, in these two diagrams along x-axis we have the rectangular component a cos theta. So here we have a sin theta. So along the x-axis we have the angle, that is we have the same vector a and same angle theta. If you observe here we have a cos theta and here we have a sin theta. So the component will vary depend on the angle of which it inclined with the axis, right? So if you observe here, the theta is inclined with the y-axis. So here theta is inclined with the x-axis. So wherever the angle theta which is inclined with that axis means always the value is a cos theta. Right? So here theta is inclined with x-axis, hence here we get a cos theta along x-axis. So here angle theta is inclined with the y-axis, so along y-axis we get the a cos theta. Right? So this is about the resolution of vector. So this one is very important concept. So by using this concept it can help in deriving the relation and while simplifying the problems, right? So this is about the resolution of vector and it is the important concept in the vectors, right? So in that means the vector with which it inclined with the axis, so that component gives along cos theta value. So here we have along x-axis a cos theta, along here we have a cos theta. Right? So here y-axis we have a cos theta, opposite to that we get a sin theta. Right? So this is about the concept of vectors, that is scalars and vectors, types of vectors and addition, vector algebra, addition of vector, subtraction of vector and the laws of vector addition, and here we have the resolution of vectors, right? So this is about the concept vectors. So in the next class we will continue or start with the new topic. Thank you.